Hey everyone, this is going to be a video on the concept of sine rule, which will be sine rule. So I'll talk about what it is soon, but first I want to tell you why this is important. Sine rule is important because it allows us to apply trig to non-right triangles. Right? So that's the key thing. So everything so far we've seen trig for right triangles. We know all the trig definitions are based on right triangles. So it seems like it's only for right triangles. So we know that sine is, this angle would be opposite adjacent, opposite hypotenuse. Sine would be opposite over hypotenuse. Cos would be adjacent over hypotenuse. But sine rule allows us to apply trig to the non-right triangles. In particular, it says that for any triangle, doesn't matter if it's right or not, the ratio of the side length to the opposite side, side length to the sine of the opposite angle, not the opposite side, is constant. In particular, it says that if you put this into a formula, it will look something like this. And all it says is that simple A would be the side opposite angle A. But I would honestly remember it as this idea rather than actually with the formula, because I think you'll remember it for much longer if you think about it actually in terms of what it actually is, rather than just this formula and a bunch of symbols. So let's do some example problems. For example, we know that 7 over, what it says is, well, for this question, it says that 7 over sine 75, that's the angle opposite side 7 is 75, so it's 7 over sine 75, saying it's equal to the, let's say call this side x, over the angle opposite that, which is sine 80. Because we know it's constant, right? It's constant means it stays the same. That's what constant means, by the way. Because it's constant, it's equal for all of the sides. If we had some, like, call this y, and this angle would be 25, you'd also have that this is y over sine 25. But that's not relevant to us. We're just going to focus on finding x. And we can rearrange this equation to make x the subject. X is 7 sine 80. And the way we rearrange is multiply both sides by sine 80. So 7 sine 80 over sine 75. Which equals, I think it should be like 7 point something. Yeah, it's 7.136. 137, sorry, meters. And that's it. And whereas for we can also use the sine rule to find angles, because we know that the ratio of 10 over sine theta is this equal to the ratio of 12 over the angle sine of the angle opposite, which is 70. And that would mean that 10, if I were to rearrange to make theta the subject, I'll first flip the fraction around. So sine theta over 10 equals sine 70 over 12. That would mean sine theta is, I can get by multiplying both sides by 10. So I'll get 10 sine 70 over 12, which equals 5 sine 70 on 6. And that would be our answer. And if you plug it into a calculator, you'll get, actually, let's not even solve for it here. 5 sine 70. Nope. You get 0.783031, sorry, is sine theta. So if you wanted to get theta, we do sine inverse of this. Which is 51.54 sine inverse of this is, I think, 51.54. Yeah, it's 51.54 degrees. Now, I guess we know what it is and how it works, but the question is why? Why is this true? Well, actually, we can figure out why by actually looking at this exact same problem from our basic understanding of trig. Thing is, we can solve this problem using basic trig, and it will basically lead us to using the sine rule in the end. And well, I guess the problem for you guys that you're probably wondering about is, how do we use trig when there's no right triangles here? Key is to draw this line. This is called an altitude. It forms right angles with the actual shape, with this side. So the altitude BH forms right angle with side AC. And when you draw the altitude, you form two right triangles. And then we're going to apply trig to both of these triangles to get this. In particular, we'll have sine. We'll first apply trig to triangle ABH. The reason is, well, because we already know one side on triangle ABH, where for BCH we don't know much as of now. And we want to really find BH, because BH is the side common to both triangles. So once we find BH, we can actually work with the other triangle as well. So we know that to find BH, that's opposite 80. This is hypotenuse, so we're going to need to use sine. So we know sine 80 degrees equals BH, which is the opposite side, over the hypotenuse, which is 7. We know that BH is 7 sine 80 then, because we multiply both sides by 7. I can solve for this, but I'm not going to, because I'll show you how we get the sine rule, how we get the sine rule when we do this, and it's better seen if we leave it as it is. So observe how we have. Now we can go to the other triangle, because we know this is 7 sine 80. And we can say, well, this is the opposite side of this triangle as well, and x is our unknown. And if we say sine 75, that's equal to opposite, which is 7 sine 80 over x. And now we can multiply both sides by x, so we get x sine 75 equals 7 sine 80. Then you divide both sides by sine 75, so it's 7 sine 80 over sine 75. And that's the exact same thing you got when you use sine rule, except just with a few more steps. But this is the true logic behind this. Right? This is where the sine rule comes from. So this is the underlying logic behind sine rule. Is you draw an altitude. Really. Logic behind sine rule is to draw altitude and then do trig on both subtriangles. You can solve this question the exact same way as well. It's very important to, I think, to understand the underlying formula as well. So that is sine rule. So that's it for sine rule. We'll leave it at that. Actually, no, one more thing. Let's go through the formal proof of sine rule. And the way we're going to do that is we're going to have a triangle where everything's unknown. Side length A, so this point's going to be, this angle's A. This side length's B, so this angle's B. This side let's call C. This angle's C. Let's not worry about C. We'll solve for A and B only. In particular, we want to show that A over the opposite angle, which is sine A, is equal to B over sine B. So this is a proof. Proving the sine rule, basically. And what we do is, well, we say that we just basically do this question again, but on this general triangle. So I first draw the altitude, just like before. And then I go, well, sine of angle B, let's call it altitude H. Sine of B equals H over the hypotenuse, which is A. Let's actually not call it H, because H can be confusing with the hypotenuse. Let's call this C and H. So it's CH over the hypotenuse, which is A. And then CH would be equal to A sine B. Then I basically do sine on the other triangle. Sine of A now. Sine of A would be opposite, which is CH again, over B this time. So we know that CH is A sine B. So it's A sine B over B. And what I'm going to do is I'm going to bring this A to the other side so that it can be with the sine A. I need to divide both sides by A. When I do that, I get sine A over A equals sine B over B. This is pretty close to the sine rule, and all you need to do is flip both fractions and you'll end up getting the sine rule. And that is the formal proof of the sine rule, which is basically doing this question, but with the general things instead of with a singular, instead of with numbers. And that is the sine rule. Hope that made sense. Bye.